All right, so let's go ahead and get started. Today, we're going to go over 6.4 logarithmic functions part 2. Today, specifically, we're going to be answering the question, how do you find the inverse of an exponential and log function algebraically? So the concept that you need to understand to be able to answer that question is this one. We already know that the inverse of a log is an exponential and vice versa. The inverse of an exponential is a log. So the inverse of a log is an exponential. Both create a one pair as long as the bases are the same. Remember rule number 3. You can do whatever you want to an equation. If you use inverse operations, you will create a 1. So if you look at this, we have a base, which basically represents an exponential expression. Okay, and you are raising that to the power of a log. Okay, so you have a base and you're raising that to the power of a log. What that does is, because they're both inverses of each other, it creates a 1, leaving you with just x. All right, so that's how you're going to be using inverses of each other. So for example, the first problem that we are going to do is we're going to do question number 2, or question 1, problem 2. All right, we have a log equation there. What we want to do is we want to find the inverse of that equation. And how do we find the inverse of anything? We're going to switch the x for the y and the y for the x, and then we're just going to go ahead and solve it. So this is now x equals the log base 7 of y plus 5. So again, all I did was switch x for y and y for x. Now, I don't have a number here, so I don't have to worry about anything. What I do want to do is I want to get y by itself. However, y is inside the log. So I need to get rid of that log so I can get to y. So what I'm going to do is I am going to raise this to the power of the same base. Basically, what I'm doing is I'm using that rule. So I'm going to raise this to the power of 7. Okay, so 7 to the power of log base 7, what that's going to do is it's going to create a 1. Okay, now remember, whatever you do to one side, you also got to do it to the other. So I also got to raise this to the base 7. Okay, so let's see what's left over. Well, that becomes a 1, which means I'm left with y plus 5, since the log is gone. And I'm left with 7 to the power of x on the other side. And now, all I got to do is get y by itself. So I'm going to minus 5. I'm going to minus 5. Now that becomes a 0. And I am left with 7 equals 7 to the power of x minus 5. I can't combine like terms, so I'm just going to leave them the way they are. And that is the inverse function. So that means that the inverse function is equal to 7 to the power of x minus 5. That's my answer. Now, vice versa, you can use the same logic for question number 1. All right. So question number 1, I have an exponential function. Same thing. I'm going to go ahead and switch the roles. So now this is going to be x equals 10 to the power of y plus 1. All right. So how do we do this? I want to get y by itself, but the problem is y is part of the exponent. So I don't know a way to bring it down. So what I'm going to do is I'm going to use a log to undo the base of 10. Now we know, and I erase this real quick. We know that, again, an exponential and a log, they're inverses of each other. So how could I get rid of that base? Well, if you have an exponential, what you got to do is do the opposite. If I have an exponential, then do a log. And what I'm going to do is I am going to log, and actually let me move this a little bit more because I'm going to need space. I'm going to log both sides with the same base as your exponential. Okay, whatever I do to one side, I do to the other. Now, what's going to happen when you do this? Well, you got log base 10 of 10, and I'm just going to write it down so you can clearly see it. Now I have log base 10 of 10 to the power of x plus 1. And then on the other side, I have log base of x. Okay, again, I'm just rewriting it so you can clearly see it. So now what's going to happen when I do a log of the same base? And remember, that's the key. That base has to match that base, otherwise it's not going to work. So what's going to happen here? Well, log base 10 of 10 is actually equal to 1. We all know that. So that means the log is gone. So now I'm left with x plus 1, which is the exponent. And on the other side, I'm left with log base 10 of x. And my bad, this is not x, this is y. I forgot to change them. Okay, so now that the log is gone, all you got to do is get y by itself, and everybody here can do that. All you got to do is minus 1, minus 1. That becomes a 0, and you're left with y is equal to log base 10 of x minus 1. And obviously, if we want to write it out the fancy way, that would be the inverse function of x is equal to log base 10 of x minus 1. And that's the answer. Okay, so that's how you're going to be finding the inverse of an exponential and the inverse of a log. Now, if you turn the page over, I'm going to go ahead and do that problem real quick because it's a little bit extra, and I want you to be able to see how to do a more complex example. So same thing, I'm going to switch the x for the y. So this is going to become an x. And now this is going to become a y. So notice that now we have more stuff. Now, before you try to get rid of that ln, because again, we're trying to get y by itself, and we need to get rid of the ln or the log to be able to access the y that is inside the log. But before we can do that, notice that we have a 3 and a 7. So we need to get rid of those two things first. So I'm going to go ahead and minus 7 first, because remember, we want to create a 0. So that's a 0. And now you're left with x minus 7 is equal to 3 times ln of y minus 1. So that's gone. Now I want to get rid of that 3. And because it's multiplying, the inverse operation of multiplication, it's division. So I'm going to go ahead and divide both sides by 3. I know that becomes 1. And I am left with ln of y minus 1 is equal to x minus 7 over 3. I know the left side is starting to look a little messy. I know I'm going a little fast. I just want to make sure that I don't run out of time on the video. But you can pause it so you can try to understand better every single step. So now that the ln is completely by itself, now I can get rid of it. So I am going to raise it to the same base. And remember, the base of an ln is an e. Same thing on the other side. I'm going to raise the whole thing with the base of e. Cool. Now that becomes a 1, and I am left with y minus 1 is equal to e to the power of x minus 7 over 3. So now x minus 7 over 3 became the whole exponent. And I want to say you know how to do the last step, which is just add 1 to both sides. So that becomes 0, and your answer is y is equal to e to the power of x minus 7 over 3 plus 1. All right. Once you think you understand how to do these problems, go ahead and get the practice sheet. Make sure that you finish it by the end of class and turn it into the sub.